All right. Now, before we dive into Injective's precompiles, let's just get our precompile basics right. You see, on most blockchains, smart contracts are just programs that run on top of the blockchain's virtual machine. Of course, you already know that. Take Ethereum, for example. When you deploy a smart contract, it gets, I mean, a Solidity smart contracts on Ethereum, it gets compiled into EVM bytecode and the Ethereum virtual machine executes it line by line, opcode by opcode, and it works. But the thing is, it's slow and expensive because the EVM has to interpret every instruction at runtime, validate it, and track the gas cost for each tiny steps. Now, enter precompiles. Now, these are in your usual smart contract. You see, instead of being deployed bytecodes that are interpreted by the EVM or other virtual machines, precompiles are basically native codes that are baked directly into the blockchain. Think of them as shortcuts or cheat codes that skips the VM entirely and run super fast optimized functions. On Injective, these precompiles are written in Go, the same language the blockchain itself is built with, and they are placed at specific predefined addresses in the virtual machine. You see, and when your Solidity contract calls one of these addresses, the EVM doesn't just run bytecode step by step. It just executes the native Go functions directly. And the result is that you get operations that are orders of magnitude faster and cheaper and more powerful than anything you could implement in pure Solidity. So, blockchains usually provide precompiles mainly for the performance. I mean, some operations are just too heavy to run in interpreted bytecode. Ethereum, for example, has precompiles for things like recovering addresses from signature, hashing functions, etc. And these precompiles, they live at very specific addresses, and calling them runs the native code through the EVM. And this is precisely where Injective gets clever. You see, most blockchains use precompiles just for low level crypto functions, but Injective, well, they take it a step further. They use precompiles as basic bridges between the EVM and the native Cosmos SDK modules. That's the magic right there. You see, the precompile makes the whole dual environment system actually work, letting you write Solidity while seamlessly tapping into the Cosmos native features at the same time. Now, I know all this can sound a bit confusing, but let's just explore this whole thing a bit further. All right, explanation time. Remember when I said Injective runs both an EVM layer and native Cosmos modules, and precompiles are basically like hot sauces or something? Well, here's how all that actually works in practice. You see, when you look at Injective, at the bottom layer, you have the Cosmos SDK modules written in Go. Now, these modules handle the core blockchain functionality. For example, you have the bank module, which manages native token balances and transfers. You have the staking module, which handles validator staking and delegations. You have the governance modules, which manages on-chain proposals and voting. So different modules handle different stuff, right? Now, these modules are fast and efficient and battle tested. I mean, they are the same proven infrastructure that powers dozens of successful Cosmos blockchains. And at the top layer, you have the EVM. This is where your Solidity contracts live, where MetaMask connects, where all the Ethereum tooling works. It's a complete, fully functional EVM implementation that behaves just like Ethereum. Now, the problem is these two layers, they speak completely different languages. The EVM knows about Solidity contracts, gas, ERC20 tokens, etc. And the Cosmos modules know about the native denomination, staking validators, and IBC packets, etc. So the question is, how do they communicate? Well, that's right, precompiles. Now, these precompiles, they in Injective, they basically act like these fancy translators. You see, when your Solidity contract calls one of these precompile functions, here's what happens. So your contract makes a normal function call to a precompile address. The EVM basically recognizes this as a precompile address and hands off the execution to the precompile Go code. And the Go function basically executes against the native Cosmos module state. and the result is returned back to your Solidity contract, and execution continues in the EVM as if nothing happened. And I don't know if you have noticed this, but the absolute beauty of all this is that both these environments are reading and writing the same underlying state. There is no EVM version or native version of your token or data. There is just one set of data in the native module with both the EVM precompile and the native Cosmos transaction reading from and writing to the exact same data. Still a bit abstract? Let me give you another analogy that will make it all click. Imagine you are in a building with two floors, right? The top floor is the EVM world. Everyone speaks Solidity, uses MetaMask, lives their best Ethereum life. And the bottom floor is basically Cosmos native module world. Handling staking, governance, token management, and all that beautiful on chain order books and everything. In most blockchain architectures, these flows they don't talk to each other. But if you want to make them talk, you would need to build complicated elevators that we call bridges, have people carry messages back and forth, reliers basically, and deal with maybe two separate versions of everything, wrapped tokens. And so if you want to move assets between the floors, lock them up on one floor, mint a representation on the other, pray that nothing breaks, and pay fee for every round trip. Now, precompiles are basically like having a magic intercom system in that whole building. You just pick up the phone on the EVM floor, dial a very specific number, which is basically the precompile address, and suddenly you are talking directly to the person on the native module floor. No elevator ride, no message passing, no wrapped anything, just instant direct communication. And even better, when something happens on the native floor, say someone transfers token using a Cosmos wallet, it's instantly visible on the EVM floor. No waiting, no syncing, no hoping, no reliers, no anything. Because there aren't two separate token balances or data. There is just one data or one balance stored in the native module, and that both floors have direct access to. So when someone on the EVM floor sends token, the native balance updates. Someone on the native floor sends token, the EVM balance updates. It's not synchronization, it's the same data access through different interfaces. Now tell me this doesn't sound cool.